Welcome back, everybody, to another codezing.org program. We're going to do a level 3 program today, so getting a little more difficult. This is going to be part of a little mini series in cryptography, and this is going to be the first one, a simple cipher. So you can find the code and an example at codezing.org/simple_cipher. So let's take a look at the code. If you make your way over to codezing.org, level 3 code, simple cipher. So this program is going to take a message input by the user and assign random numbers to each unique character and make kind of a code, right, a secret code. So let's give it a try here. So we'll do secret message test and we'll submit. And here is our encoded message, our encrypted message, and it is a series of numbers, and then on the side you can see it generated a key as well, and it tells you that 91 is equal to blank, 16 is equal to capital M, and so on. If you replace the numbers with the letters in the key, you'll get back our secret message. So kind of cool. Let's take a look here at the code. So if you scroll to the bottom, you can get the code, copy the entire thing, and open up Spider IDE. If you don't have Python or Spider installed, then you're probably on the wrong level. You probably need to back up and go to level 1. But there's links on the website to help you get it installed if you don't have it. So the first line of code here is import random. We've seen that a lot in generating these games so far, that we're going to have to make some random assignments of the numbers to the letters, so we're going to need the random library. The first step here, like usual, is interacting with the user. You need to get their message before you can do anything with it. So this is we'll put type message to the console and then assign that input to the variable message. The next is creating an empty dictionary. So this message dictionary is going to be the dictionary that holds the characters and their assigned secret number, I guess, matching up the characters to the numbers. And if you remember from other lessons, Python dictionary is created with the curly braces, and then inside the dictionary you will have a key, a colon, and a value, and then the multiple keys and values will be separated by commas. Value 2, and then you can easily look up the value based off of the key. So we're going to create a key, which will be the letter, the character, and the value will be the number, and we'll do that in the loops below. But first we need to create an empty dictionary as a placeholder in the memory so that we can access that later in the code. On line 6 here, we are going to generate a random sample of the characters, a random set of numbers that will be within the range 0 to 100. So that should cover every character that somebody puts in a message. So it'll assign a random number from 0 to 100, and we are going to sample the length of the message. So we will have more than enough. So even if every character was different and unique in the message, we should have enough to cover that. So let's just print out cipher match, and you can see what it's doing. And then down here, just so we don't run this part, I'm going to use these 3 quotation marks. So if you put 3 quotation marks in a row, it treats it as like a major comment. Usually they're done at the beginning of the message to give you, or the beginning of the code to give you details about who created it, what to do with it, how it works, type of stuff. But I'm just going to do that so it blocks this part out and won't run it, because we just want to see cipher match. So let's run it. test message, and we can see that Cipher match created a Python list, which is denoted by this square bracket, and it drew a random number between 0 and 100 for the entire length of the message. So we won't need to use all of those because there were some repeated characters, but it ensures that you'll have enough random numbers to match up as you proceed through the code. So let's look at the next batch of code here. We'll block off the bottom. So this is going to create the Cypher key, and you can see I put in a comment here to help you understand what's going on in the code. This is always good to do. Previously I wasn't putting in comments. I was hoping that as you go through maybe you would add your own comments, but I put one in here. So this part of the code is going to create a Cypher key. And so this comment is started with a hashtag and a space, and then you can type in your message to your fellow programmers to help them understand what your code is doing. And Python won't try to run that as part of the code. So we're starting out with a count equal to 0. So our variable count is equal to 0, and you can see we're going to iterate. We're going to increase that count for 1 every time we add a letter to the dictionary. So for letter in message, so what's message is going to be the input from the user, and letter is going to be our looping variable. So letter, you could make letter whatever you want. I just made it letter because it's going to loop through the letters. So for letter and message, let's have it print out letter so we can watch it work. Letter. Oops. And as I've noted before, you can't mix and match the quotes. So when you go to put in a text string, you can use double quotes or single quotes, but you can't mix and match. So print out letter, and then if letter is not already in the message dictionary, so our message dictionary is starting out blank, but we're going to start adding the characters to it. This test to make sure that we don't assign 2 numbers to the same letter. So if the letter is not already in the message dictionary, then I want to take the message dictionary and set the value for the key letter equal to the cipher match count. So it's going to find the first letter, add it to the dictionary, and set the value for that key equal to the first item in this list. So we'll print out cipher match so we can see it, and then let's walk through this cipher match. So we'll print out the cipher match first. It's going to print out the letter, and then let's print out the message dictionary as it builds. So we'll print out the text message dictionary, and then it'll actually print out the dictionary. And then why don't we also print out count so we can see that that is iterating as we expected. So let's run this chunk here. So type in our message, secret message. We can see it printed out a lot of stuff because it's looping through all of the items. So the first thing it did was create this cipher match up here. So it created a random list like we saw before, and now it's going to begin the loop, and it printed the first letter was secret message. So that's right, that's our first letter. It was not already in the dictionary, so it added it. It added S to the dictionary, and then set the value for the key S to 46, which is the first item in our random list. And it upped the count +1. So next, it's looking at letter E, which is here, our secret message. It was not already in the dictionary, so it added the lowercase e and assigned that the value of 25, the next random number. It's going to the next one, letter C, which is there in secret message. It did not find that already in the dictionary, so it is adding C and then adding the next random number. And you can see it keeps going. Let's see what happens when it finds one that's already in there. So this goes to letter E, and you can see that it realized that this, if letter not in message dictionary, evaluated to false because it is in there. It was already in the dictionary, so it didn't add E to the dictionary again, and instead went straight to the next letter, T. So it didn't do anything on E, and then it goes to T and keeps adding all those characters and assigning the random values that we generated in this list. You can see it does that all the way through the entire message until it gets to the end of secret message, and we have a full dictionary of each unique key, unique character, and an assigned random value. So kind of cool. And then the last E, it didn't do anything because it's already in there. So kind of cool. What else do we have? If we continue through the code, now it is going to generate the encoded message, which is the secret message that we saw. It's going to generate this piece. So we just generated this dictionary, and now it's going to generate this list to display. So let's, so we saw that in action. I think all that makes sense. I'm just going to comment these out instead of deleting them in case we want to use them later. So it's treating those like comments, like the create Cypher Key, but really it's code that I don't want it to run right now. And we can get rid of, well, I guess we might want cipher match so we can see what it's doing. We might even want the, I guess it's going to show us message dictionary anyway. So let's just run it. We got encoded message. It's starting out as a blank list, and you can see we're going to append the matches. So let's see, print letter and print encoded message. What did I do? Oh, I keep mixing my quotation marks. Encoded message. So we're going to see it build. We're going to see it's going to look at each letter. It's going to find the match in the dictionary. Right? It's going to look at message dictionary, which is what we would have just created. It's going to find the key, which is the unique character, and then it's going to pick out the number. So let's watch that happen. And oh, I forgot to get rid of my quotes. Secret message, and we can see it's going to create a brand new cipher match, right? A brand new list of random characters, and it's going to create a dictionary, which is down here. We printed out the dictionary, and this is different than the one before, right? Because each time you run it, it's going to create a new random mix. So this is the key, and what it's going to do is look at the letter. So it's going to look at the letter in our message. So we can see it started with S, and it's going to look up in the dictionary what is S equal to. It finds S here and brings back the value 12, and then appends that to our list encoded message. So that's what this step is doing. It's saying append to the list encoded message, append the value that you find in the dictionary. You go to the next one, lowercase e, and it looks up lowercase e here in the dictionary and finds the value 2 and appends that to the list. Finds the letter C, finds that the value is 79 and appends that to the list. And you can see it's building this list of numbers. And at the end, you're going to get the message key and the secret message. And you would obviously give the secret message and the key to your friend, and they can then decipher your secret message. So let's run it one last time without any comments. And super duper secret message. And we can see it gives us the key and our secret message. So cool. And it uses for loops to build those up. And we've seen those before, but it's another usage of it. We're going to use for loops a lot in the games. So interesting to see a different application of that, and using the dictionaries and the lists to build up kind of a lookup system. So have fun with it, play around with it. You know, you could change this range to be bigger, and then the numbers would be bigger. You could go up to like 1,000,000, right? But then your secret message is going to be huge numbers. What else could you do? Instead of numbers, you could assign something else to it. It's just going to draw a random sample from whatever this value is. So this value could be a list, right? You could have it do, you know, you'd probably make it separate, but secret list. And if you did a secret list of words, dog, cat, I don't know, you could use all animals or all something else. What are the bird? All right. So if I do it like this, I put in secret list. It's going to draw a random sample from secret list and then match those up. As long as my message isn't longer than 4, it should work. Let's give it a try. Type my message. Good. We can see that my secret message is now bird, dog, dog, cat, and my key is G equals bird, O equals dog, and D equals cat. So it's a simple way to show you that this is easily changed to make it more complex, and it gives you a good base for making something cool. If you come up with a cool new version of this game, feel free to send it to info@codezing.org, and we can post it to the website, and other people can learn from what you're doing, and you can show your parents how hard you're working at computer programming, how good you're getting. If you have any questions, you can post those to the comment section under the video or email info@codezing.org. But have fun playing around with it, and hopefully this was fun for you.